Hi, everybody. Today we're going to add a step on the top of our graphing real-world situations, and we're going to learn how to write those function rules from the words. So our goal today is to model real-world problems with linear functions. We're going to write the rules, and we're going to graph them. So if we look at page 298, there's an example about customers getting a $5 coupon, basically. So there, the words are there. You know, each customer receives a coupon for $5 off. The rule is that we take the number of coupons. So basically, I'm standing there handing out coupons as people walk by. So they get $5 off. So for every customer, the total value of the coupons will be $5. So if there's only one customer, 1 times 5. Now, if there were 2 customers, you know, that would be $10 off total. If there are 15 customers, 5 times 15, it would be 75. So again, we take the words, we change it to a rule. When we write a rule, we define our variables. There's 2 of them now. What's what here? So we let everybody know that X is going to represent the number of customers. So when we put a number in for X, it's how many customers I handed a coupon to. And then Y is going to be that total value of the coupons. And notice, because it's money, I'm putting the dollar sign there. So everybody in the world knows what currency I'm using. I'm going to create a table. We've done this a lot. Now notice I'm not using the fave 4 because it doesn't make sense to have negative customers or negative dollars. So you should be happy. Yay! Don't have negative values here. And notice I'm not necessarily going by ones because I'm not just going to hand out 4 coupons. So I'm going by 5s just to make it be more realistic. And then as I put 5 in, 5 times 5 is 25, right up to 5 times 20 is 100. And then you guys know that we're going to create a graph from our last video. Boo to the book. They always forget to put a title. It's such a bad move. So $5 coupons is what I'm calling this one. And I had to write that in because they didn't write it. The number of customers is our input, our X. And the dollars that those coupons are worth depends on how many customers. That's our Y. I'm going to set up my scales, and notice I'm going by 5, 10, 15, 20, 25, 30. And I decided the value of the coupons, I've got to get up to at least 100 here. So if I go by 10s, my points fit. And then I plot my points. So basically what we're going to do is, like writing equations, writing a rule from words is the same, except there's going to be 2 variables this time. So when we were doing equation solving before, you guys are really good at writing like the 2-step equation and remember the break-even problems, you write those equations. See, what has changed here is we have an input and an output. So there's 2 variables. We're going to define what those are. What that means is, I recommend, since we're graphing, you do use X and Y. It makes it a little bit easier. You got to figure out who is X and who is Y. Which one depends on the other. So in the last case, the dollars depends on how many coupons go out. I get to decide how many coupons go out. That's my independent choice. That's the input variable. That's the X. Meanwhile, the money is waiting to see how many coupons went out. It's dependent. You can use Y, you can use f of X, but I recommend Y since we're graphing. It just helps you remember who's who. So when we come up with who is who, we then say, well, X is going to represent. We're going to tell people what X represents and what Y represents. That's defining the variables. And then we're going to write an equation. So basically, your dependent variable is hanging out by himself, waiting for the math to happen. So you'll write Y equals. So in the last example, the total amount of money for the coupons equals, and now I've got to put the other side is where the math's going to happen. The other side will tell what operations to do, and oftentimes it's some money times that independent variable plus, you know, some other amount, as you're going to see. So it would be Y equals something being multiplied by the input variable, oftentimes adding a value, sometimes it's subtracting. So it's the best thing to do is kind of do an example. So again, we just looked at the one on page 299 with the coupons. You know, you had to, they kind of told you what to do here. And, you know, so you take it, you take your information in words, you write a function rule, you create a table, and then you do a graph. At the end, you kind of decide whether you're going to put the line in it. That goes back to the discrete and continuous. Right now, kind of boo on the book because they didn't draw a line in, because this is discrete. That's true. You're going to go 1 coupon to 2 coupons to 3 coupons. But because of my scale, if I just leave that dot there, I didn't catch 1, 2, 3, and 4. I didn't catch 6, 7, 8, and 9. So I actually do have to draw, and I'm going to call it array. I do have to draw that in to catch those. So even though it's a discrete graph, I am going to put that line, array, in. So, what about all those numbers in between? We're not going to put all the dots in. So we would actually draw the array in. So boo to the book. Okay, so let's do a better example together. We'll do this one together. I'll let you practice one out of the book, and then we'll be good to go. All right, so advertising in a local newspaper, in this case, it's the New London Day, cost $20 and $4 for every line of text. So we don't do classifieds as much in the newspaper. They still exist, but basically you have to pay for an ad, and you pay a set fee and then a per line of text cost. We're going to model that advertising cost with a function rule. We're going to make a table of values, and we're going to graph it. So the only thing that has changed from the last video is they didn't give us the rule. Once we have the rule, it's going to feel like what we did last time. So before I start here, I kind of have to think about what are the two things that are varying? What are the two variables? What do I get to decide right now? I get to decide how many lines of text I'm going to write. That's my independent choice. That's going to be my X. So I'm going to let X be the number of lines of text. What's the other thing that varies? Well, it's the cost that I'm going to pay. Depending on how many lines of text I make, I'm going to have, the more lines, the more money I have to pay. So Y is going to be the total cost. And notice I put the $sign in there so everybody knows what currency I'm using. I am now going to write a function rule that uses the X, the Y, the 20, and the 4. I need to put that all together. Remember that our dependent variable is going to be hanging out over there waiting for the math to happen. So now we have to figure out the math. How many times do I pay $20? Once. It's a constant. How many times do I pay the $4? It depends on how many lines. So the $4 needs to get connected to the X. Like 1 line of text would add $4. 2 lines of text would add $4 or 8. 3 lines of text would add $4. So the $4 is what is varying. So I'm going to attach that 4 to the variable. And there is my function rule. I'm now ready to make a table. So when I go to do my graph, right, the first thing I'm going to do is to create a table. I'm just putting this up here. Here's the function rule. So I need to create a table, and I need to pick inputs that are reasonable values. So what I'm going to do is just talk this through, and then I will show you the completed one. So I'm not going to use the fave for it. I'm not going to buy negative lines of text. And I am going to start with a 0. Even that kind of like Mrs. Woodruff, you wouldn't have 0 lines of text. You wouldn't be doing this. But what that does is anchors the graph to the y-axis. If I put 0 in for x, I'll have a point on the y-axis. And so the graph doesn't look like it's just floating. It kind of gives you a start point. It's called the initial value. So I'm going to start by putting in 0. Now for this case, if I'm going to put a classified ad in, I'm only going to put a few lines of text. So I'm not going to be like putting 100 lines of text. So you will see me kind of go 0, 1, 2, 3, 4 on this particular case, because that makes sense. So I'm going to pick those X's. I'm going to do the math, and then I'm going to graph it. So right now, 0 times 4 would be 0 plus 20. So I would have 0, 20. Then I would put 1. 4 times 1 is 4, plus 20 would be 24. Then I would put 2 for x, and 4 times 2 is 8, and I have 28. I'm going to build the table, and I'll show you that in a second. When I go to graph it, I now have to sort of set up the graph, right? So I'm going to put a title. The book never seems to do this, so I'm going to call it advertising cost. My definitions of my variables are going to be my labels pretty much on the X and Y axis. So, X is going to be the number of lines of text, and the cost in dollars will be my Y. I'm going to flip over so you can see why I put these numbers in. So look at my table. Here's the table. So I need to have, lines of text aren't going to go that high. So that's why you'll notice I'm kind of 2 blocks for each line. If you had done 1 block, that would have been fine too. But I don't need to go by 5s, right? Because I'm going 0, 1, 2, 3. So going by 1, so you notice I'm even stretching it out further. Trying to get my graph to use up most of the graph paper I've allotted. Now, if I look over here, that should be 24. Let me just fix that. I don't know how that got dropped. Oh, and it's in black nonetheless. Sorry. Okay, so if we take a look at that, you can see that the table starts at a value of 20, and I'm not even going past 32. So if you look, I'm kind of going by 5s here, so that I get up to a high of 50, and over here, again, I already explained that. So then I'm going to plot my points, 0, let me get that guy back, 0, 20, 1, 24, which would be a little below 25, 2, 28, which would be just above the halfway mark between 25 and 30, and 3 and 30 is a little bit higher. And, you can see that they fall in a straight line, kind of. They're kind of close. I'm just looking here because I just got a message. So anyway, let me get to that in a second. Sorry. So now if we take a look here, we can put our line in, 1 arrow, because we're not going to have negative lines and negative cost. And then see, we're going to kind of ring that point. Why am I ringing that point? Let's go back. Model advertising costs with a functional table of values and a graph. I thought there was a question here that was going to ask. I think I just must have asked it here. Oh, use the graph to find the cost of a 4-line advertisement. Sorry, I missed that down there. So here's 4 lines, and I go up and I hit the graph, and it looks like it's just above. Like if this would have been in the crosshairs $35, a little bit more, it's about $36. And that's how I can use the graph to make predictions. I got interrupted in there. I'm just holding here to make sure you are okay. So we define our variables, who's X, who's Y. We write the function rule. Use the function rule to make a table. And the table needs to be reasonable inputs. Now we look at our table, and we will, on our graph, we will set our scales so that it fits the data. We look at the minimum and the maximum. Don't forget a title. Labels are easy. They're what we defined before. Once we've done the math, we plot the points. We draw in our line and put arrows appropriately. And then we can use that to extend. So, I needed to be able to see 4 here so I could see it on the graph. And I show Mrs. Woodruff, I know what I'm talking about, because there is where the 36 came from. So I put a big ring there to show me. Okay, so basically now I'm going to have you try to do what we just did, okay? So on page 299, there is a got it. Now, if, they don't always give you a lot of room here, there is some usually green margin space as you need to. So you're going to, a store sells nuts for $5.95 per pound, and you're going to write a function rule that represents the total cost of any pounds of nuts. You need to decide what your variables are. You're going to define them. One is X, one is Y. What is your choice here when you're buying nuts? And then what would the Y be, the dependent variable be? They're already telling you that they want you to use the inputs of 1, 2, 3, 4, 5 pounds of nuts. They want you to do the math in the table. And then they want you to graph it over here. And they very nicely already sort of set up the table for you, of course, without a title. You're going to put your labels and finish this one off. The Ed puzzle is going to stop for you to kind of be able to do some of this, walk through some questions with me and do this, and then we'll come back and check it. Okay, guys, so here is the answer key. I used the C and the P, I think because the answer key had C and P. So basically C is your Y equals the cost in dollars. P is the pounds and nuts, which would be X. So you know, this is your Y and that's your X. And it doesn't matter what variables you use as long as they match appropriately. So the Y, the dependent variable, in this case C, would be your cost in dollars. The input variable, which the book uses P, would be maybe X, and that's the number of pounds of nuts. You got to have the dollar sign. You need to have the word pounds, not just nuts, okay? So we're going to put 1 in. That's why I had to use the P and C, because they use that. So we're going to put 1 in for our independent variable, in this case P, or if you have an X, 595 times 1, 595 times 2, 595 times 3, 595 times 4, and times 5. And now I'm getting ready to plot the points. Like I said, they very nicely gave you the scales. But look, we only had to go up to 5. So 1, 2, 3, 4, 5. We go a little further to be able to make a prediction. And look here, we have to get up to at least 30. So notice they're going by 5s to be able to do that. When we plot our points, they also didn't put the 0 in. So they would sort of have it floating up here, and notice they did connect it down to the fact that if you bought 0 pounds, you paid $0, okay? So that just kind of makes it anchor to the y-axis, 0, 0. Plot my points, 1, a little bit more than $5, kind of 6, right? And then 2, almost to $11, 3, almost to 18, 4, about $24, and 5, about just below 30. And then we're going to draw that in. Now, the other thing that your book fails at right now is the arrow. So we have to decide, you know, are we going to put an arrow in? And there should be, let me make it a little smaller, it'll be huge. There should be an arrow out on this end, but there should not be an arrow on the other end because you're not going to buy negative pounds. So it is a ray. And that would be the graph showing your snack purchase or your nut sales or whatever you want to say for this one. So what we're going to go forward now is we're going to practice. When I see you next in class, there'll be a reteach video so you can see it again, and then you'll have a chance to practice. I hope you guys all have a great day.